Objective 4 is to add and subtract rational expressions. So remember, there are two cases. To add and subtract rational expressions or add and subtract fractions, you have to have the same denominator. You have to have a common denominator, remember? So the same thing here for rational expressions. So let's say we're already given one that has the same denominator. So for a, let's say we have 3x plus 2 over 3x plus 4, and we are adding 3x plus 6 over 3x plus 4. So note here we have the same denominator, so we're just going to be adding across. But before we do anything, just like before, we want to figure out the domain. Before we make any changes, we want to look at the beginning and see what that domain is. So if you have to factor out the denominator, you go ahead and do that first. This one is already factored. It's just a linear thing. So we know that 3x plus 4 can't be equal to 0, which means our x cannot be equal to a negative 4/3. Remember, 3x plus 4 equals 0. So 3x equals negative 4, so x is negative 4/3. Okay, so that is the only thing that is going to limit our domain here. So now we can actually add straight across because we have the same denominator. So the denominator stays the same, 3x plus 4. Numerators, we have 3x plus 2 plus my 3x plus 6. Now because it is a plus, you don't really need the parentheses, but I did that just out of habit to help with the subtraction later on. So because this is a plus, this parentheses aren't really needed. So we have 3x plus 3x, which is 6x. We have 2 plus 6, which is 8, over 3x plus 4. And once you have this, then you go back to our simplification steps from previously and see if that simplifies. So we're going to factor the numerator, and we can take out a 2. So we have 3x plus 4 over 3x plus 4. So now we see we have the common denominator, we have the common factor here, so 3x plus 4 cancels, and we're left with just 2. So when you add these two together, we do just get 2 with no x's, they all cancel out, but it's only going to work if x is not equal to negative 4/3. Okay. Now let's look at a subtraction one. So let's say we have x squared plus 3x all over x squared plus x minus 12, and subtract out x squared minus 12 over x squared plus x minus 12. Okay, denominator is the same, but we do need to figure out the domain before we do anything else. So we factor x squared plus x minus 12. I want two numbers that multiply to 12 and are subtract to 1. Well, that's going to be 4 and 3. So I'm going to go ahead and rewrite this. So I have x, we want a positive 1, so positive 4 and x minus 3 minus x squared minus 12 over x plus 4 times x minus 3. So our domain so x cannot be equal to a negative 4 or a positive 3. Okay, now I got my domain, I can actually do my subtraction. So my domain stays the same as x plus 4, x minus 3. And numerator, we have x squared plus 3x minus an x squared minus 12. So note here, the parentheses are important here. So I'm subtracting this entire polynomial, not just the x squared. So distributing that negative, so we have x squared plus 3x. We have a minus x squared and a plus 12 all over x plus 4 times x minus 3. Combining like terms, x squared minus x squared is 0, so then we just have 3x plus 12 over x plus 4 and x minus 3. Now the numerator can be factored, so we can factor out a 3, so we have 3 times x plus 4 over x plus 4 times x minus 3. We have a common factor here, so x plus 4 cancels, so we're left with just 3 over x minus 3 as the solution to that subtraction. Now, that's if they have like denominators already. So what happens if we have to find a common denominator? So before, previous math classes, we'd always abbreviate that as LCD, your least common denominator. So to find this, we're going to factor everything, and then we're going to go through each of these, and we're going to include all of the factors, including all the multiplicities for each one. So looking at an example, so let's say we want to find the LCD of 5 over x squared minus 8x and 7 over x squared minus 9x plus 8. The numerators for this doesn't really matter. So we want to factor both of these. So x squared minus 8x would factor, you can factor out the x, so we have an x times x minus 8. This one we want to multiply to 8 and add to negative 9. So that would be a 1 and an 8, both negatives. So x minus 8 and x minus 1. So to get the least common denominator, what we're going to do is we're going to take all of this one. So we know we need to have an x and an x minus 8 in our common denominator. Now I'm going to look at this one and see, is there anything in here that is missing from here? Well, I already have an x minus 8, but I also need an x minus 1. So I'm going to include that. And you do that with all of them. So if you have multiples, you just keep going. So this would be my least common denominator between these two fractions. So looking at the next example, and I'm just going to write down the denominators here. So we have a 2x squared plus 5x minus 3, and we have a 6x squared plus x minus 2, and a 3x squared plus 11x plus 6. So we need to factor all three of these. So 2x squared plus 5x minus 3. So this one, my a is 1, so I have to do a little bit differently. So we have to use like the AC method. I'm going to do it slightly different on here, but you can go back and look at the previous section if you want to remind yourself on how to do the AC method. So my AC is 2 times negative 3, which means I want my numbers to be factors multiplied to 6, and they're going to subtract to 5. In this case, 6 minus 1 is 5. So what I'm going to do is figure out the numbers here. So again, this is a little bit different than what you've done the AC method. I'm kind of doing it all in my head instead of on paper. So I know that these first two numbers have to multiply to 2, so I know it has to be a 2x and an x. And so I want this number that multiplies together and this number that multiplies together. One of them has to be 6 and one of them has to be 1 in order to get the 5. And that has to be factors of 3. Well, 3 times 2 is 6 and 1. So if I have a positive 6 from 2 times 3 and I subtract 1, that will give me the 5 in the middle. So again, you can do the AC method, but that was just kind of how my mind works in factoring this one. So this factors 2x minus 1 and x plus 3. This one again, we have 6x squared plus x minus 2. So if I again do the AC method kind of in my head, so 6 times negative 2 is 12. So I need a number that, or two numbers that are going to multiply to 12 and are going to subtract to 1. So I know I'm going to have a 4 minus 3. So when I set up my two things here, I know that I want these to multiply to either 4 or negative 3, and these are going to be the other one. So I know that, like this, there's multiples 1 and 6 or 2 and 3. This one has to be 1 or 2, so I'm going to go ahead and start with 1 or 2. Now I can't get a 3 from multiplying to 2, so I know that the 3 has to go with the 1. So I have to have a 3 times 1x to get the that negative 3, and I know that this has to be a negative to make that negative 3. And then you get a positive 4, so this is going to be 2 times 2. So 2 times 3 is 6, 1 times 2 is 2, and then we have a 4 minus 3 to give me a positive 1. Okay, so 3x squared plus 11x plus 6. again, because this is 3, I know this has to be a 3x and an x. And 3 times 6 is 18, so I want two numbers that are going to multiply to 18 and add to 11. So that would be 2 and 9. So the 3 has to go with the 9, so 3 times 3. And this has to multiply to 6, so this also has to be 2. So 9 and 2, I want both of them to be positive. Okay, so we have all the denominators factored. So now to find the least common denominator, I'm going to take all of my first one, so 2x minus 1 times x plus 3. And look in the second one and see what I'm missing. So I already have a 2x minus 1, but I need a 3x plus 2. So I'm going to add that one here. Look at my third one, I have a 3x plus 2 already, and I already have an x plus 3, so I don't need to add anything else. So my least common denominator is the product of these three factors. Okay, now let's put this into practice. So for C, we have 4 over x squared plus 6x plus 9 plus 4 over x plus 3. Okay, so first we have to factor. So this one, x squared plus 6x plus 9. So multiply to 9 and add to 3, or add to 6, which is a 3 and 3. So we have an x plus 3 squared plus 4 over x plus 3. So again, before we do anything else, we want to note the domain. In this case, x can't be equal to -3 for both this denominator and this denominator. Okay, so now I need to find the least common denominator so I can add them together. Well, this one is x plus 3 squared, which means I have two x plus 3s. For this one, it's just one x plus 3, which I've already included. So my least common denominator is just that x plus 3 squared. Now, what I'm going to do is I have to get both of them in that common denominator, right? Well, this one already has it, so that one stays the same. Now I need to make sure that this fraction has that least common denominator. So remember when we had just regular fractions, you'd have to multiply top and bottom by that least common denominator. So we're going to do the same thing here. We're going to multiply top and bottom by that. Although it's actually what's missing, right? So if you had like a 1 over 4 and a 1 over 8, you want to get this into an 8, right? So you want to multiply by what's missing. So you multiply this by 2 over 2 to get 2 over 8. So here, between the least common denominator and this one, I'm only missing an extra x plus 3. So I'm going to multiply the top by x plus 3 and the bottom by x plus 3. So instead of x plus 3, I have x plus 3 squared. Okay, so now I can actually add them together. So I have a 4 plus 4 times x plus 3 all over x plus 3 squared. So then just comes simplification. So distributing the 4, so I have 4x plus 12 all over x plus 3 squared. So this becomes 4x plus 16 over x plus 3 squared. And then if I factor the top, I have 4 times x plus 4 over x plus 3 squared. So nothing else can simplify, so this would be my simplified sum. Okay, for D, last example, the sum we're going to subtract. So I have a 3x over x squared plus 3x minus 10 minus 2x over x squared plus x minus 6. So factoring everything first. So this is a 1, so multiply to 10 and subtract to 3, so that would be a positive 5 and a negative 2. And this one is going to multiply to 6, subtract to 1, so I want a positive 3 and a minus 2. Noting my domain, For this first one, I see that x can't be equal to -5 or a +2. And this one, it can't be equal to -3 or +2, which I already have written. Okay, now finding least common denominator. So everything from my first fraction, so x plus 5 and x minus 2, and everything I'm missing. So I need an x plus 3, and I already have an x minus 2. So this would be my least common denominator. So to get this into least common denominator, I already have an x plus 5 and x minus 2. All I'm missing is x plus 3. So multiply top and bottom by x plus 3. So I have 3x times x plus 3 all over x plus 5, x minus 2, and x plus 3. And then for my second one, I am missing the x plus 5. I have the other two. So I have 2x times x plus 5 all over my common denominator. And now I can subtract across. So I have a 3x times x plus 3 minus a 2x times x plus 5 all over x plus 5, x minus 2, and x plus 3. Okay, so simplifying the top, distribute the 3x. So I have a 3x squared plus 9x. Distributing the negative 2x gives me negative 2x squared minus 10x. All over x plus 5, x minus 2, x plus 3. Okay, 3x squared minus 2x squared is a 1x squared. 9x minus 10x is a minus x. 2x plus 5, x minus 2, x plus 3. Factor numerator just to make sure I can't subtract, or not subtract, make sure I can't cancel. That becomes an x times x minus 1 over x plus 5, x minus 2, x plus 3. So nothing cancels, which means that is simplified.